Thank you, sir. Feel kind of awkward.
Right. Hello, everybody. We're all suitably refreshed and ready for the last session. So to kick off the last session, we've got Sanki Hong. He is our working group 10 convener here at ISO TC 211. And Smart Cities is his bag. So he's going to talk about a framework for gap analysis for geospatial standards of smart cities. Sanki.
Thank you, Alan. Good evening. My name is Sanki Hong, a working group 10 convener of this ISO TC 211. This may be a little bit academic or too technical for the standard in action seminar, maybe, because we usually talk about much more broader topics in this seminar, but I thought that the smart city is a very hot topic, and I've been thinking about this and how to approach this issues regarding the role of geospatial information standard in smart city context. So that is why I came up with this topic. I'll just go through the brief introduction and then the gap analysis framework. Then I'll give you some example of gap analysis in the case of indoor-outdoor seamless navigation. So, and then what's next? So the gap analysis, that is going from current state to desired state. And to get there, gap analysis provide what do we need to do to get there and how do we do that. So there seems to be a lot of gap analysis these days, and there are some analysis methodologies. We have a JRC report, and then we also have a RAMI from Germany, and we also have ISO IEC JTC1 Working Group 11 on the three-dimensional model mapping for potential requirements of smart cities. And one thing, I'm sorry that I made the slide so tiny. It's intentional. Then I can't see them. And the last one on the right, the bottom right-hand side is the smart grid reference architecture model. And mapping use cases to that architecture model, which I pretty much copied and used to do it. So the framework that I am proposing is to use this three-dimensional axis, and with x-axis for geospatial data lifecycle, and z-axis for interoperability levels. Then y-axis horizontal, another axis for actual smart city reference model layers. So I'll go to that one by one. So the main process would be to analyze the current state. We use some use case development method. Then we develop use case scenario as an output of that development. Then we will put that use case scenario into this framework, the XYZ framework, and mapping it to the smart city reference model architecture. So the level of interoperability is the z-axis. As the 19101 part 1 says that the interoperability levels increases vertically for greater exchange of meanings. So we have different levels of interoperability. I am not exactly using that semantic up to the semantic interoperability level yet. I am basically using the smart grid reference architecture for the level of interoperability, starting from component layer to communication and information function, service, and business layers. Then for geospatial data lifecycle, the United States UNGGIM Integrated Geospatial Information Framework Strategies Pathway 4.0 shows that says that we have collect stage, dispose, store, access, and distribute stage for geospatial data lifecycle. So I pretty much use that for axis. Then we will actually try to map it to the another horizontal axis, which is smart city levels. In smart city reference model, you have different layers starting from service, sensing, network, then data, then business and application layers. So we have this two horizontal axis, then the vertical axis to deal with three-dimensional frame. And I'll give you a short example of that. Indoor-outdoor seamless navigation. There's actually a New York item proposal just passed to writing a technical report on this gap analysis of this seamless navigation thing. So it is now the work is actually starting. So it's kind of showing what we will be doing in terms of gap analysis. And ISO 17438 Part 1, which is ITS standard, ITS Working Group 17, ITS TC204 Working Group 17 is developing this line of standard, and that is personal and vehicle navigation for ITS stations. And in that standard, there are some specific use cases for personal and vehicle navigation. So I take that use case and use it as an example to show how this mapping process is going. So there are some stages down there with yellow arrows. So we start with use case analysis. Then we develop the component layer first, then the business layer, and function service layer and information layer. Then lastly, I developed a communication layer. What do I mean by that? It's very small. So it's just a table of use case scenario in the standard that I just mentioned. That there are some use case cluster and description, and the use cases in that standard with numbers. So I take that, and if you look at the picture there are several layers from city physical infrastructure to application layers. And in the standard, they identified units of indoor navigations. So there are a whole bunch of components spread around all these layers. For example, number one down there, lower left-hand side corner, personal and vehicle ITS station part. There's a ITS station mobile subsystem component and vehicle subsystem component. So there are several components in those layers that needs to be mapped. Business layer is a little different story. The business layer shows the area which is affected by the use case and consequently influenced by underlying business objectives and economic and regulatory constraints. So it is not really a technical mapping going on with this business layer, but we do need this as a regulatory and economic context for this. Then development of function service layer is a little bit kind of hairy to explain it, but the basic idea is take the use case description and match that to the specific components in that component layer in the ITS service. So there are several matching arrows going from left side to the right-hand side. And those arrows, actually each of those arrows represents something that needs to be done in terms of standardization. And the way that we try to use this is to see if there is any existing standard to satisfy this requirements, or if not, then there's a need for a set of standards to do that. And probably the information layer is mostly very much related to what the geospatial standards are doing at this point. But this is not the only layer. I emphasize this is mainly the main layer that we will focus on, but there are other layers that we need to look at. So we have on the left-hand side, we have a use case scenario, and we take part of it to the geographic data lifecycle, geospatial data lifecycle, and see if there are any standard that are missing to support this. And communication layer is to describe protocols and mechanisms for the interoperable exchange of information between the use case scenario, considering the groups of communication networks and wireless technologies for IoT by geospatial coverage range. So there are different geospatial coverage range and the IoT coverage range that we need to consider, and those are not really the realm of our TC so far, but we may have to look at it and how they are relevant to us. And before I move to this what's next page, this is a kind of a three-dimensional framework with all those different things going on. So it is kind of hard to understand at first, but the thing that I was a little bit worried about at first was how to handle all these different domains. For example, in smart city, there are navigation services, there are other services. Then how can we put those different domains into this framework? And I thought a lot about it. And the only way that I came up with that actually treat each domain in terms of use cases, for example, or a service by service. So this kind of a gap analysis framework should be done for a navigation service. Then the same kind of framework can be applied to different type of services like smart energy services and other kind of services. So I think there is no universal way of handling all that and try to figure out the gaps other than actually taking each domains or services one by one and put it into this framework and then figure out which standards are, where are those gaps in that different level and different XY cross section. So that is main logic that I am doing. So I just gave you the example of a navigation service, but there needs to be other services that needs to be analyzed, and we need to do sort of a series of work to do it. And the final slide, I think, is that the use cases for different domains needs that the geospatial standard experts cannot understand all those different domain services. And domain people, they need to understand what geospatial standards can contribute to. So usually it is a very good idea to have a technical report about the current state and then try to join the efforts together, forming a joint working group or joint workshop, and do the joint project. And those are the steps that I recommend to take. So I think that would be the last presentation. Thank you.
Thank you very much, Sankey. Any questions?
Yes, Scott.
Thanks, Anki. That was actually really interesting. And one of the things that just occurred when you're describing doing your gap analysis and identifying those standards which solve some of the gaps, are you still having to deal with the gaps between those standards that are not themselves interoperable?
That's right.
And how are you addressing that? You could have a whole lot of little tiny slots that connect things, but if they don't talk to each other,
That's
you
right.
have a whole new set of gaps.
Yes, but yeah, you're absolutely correct. And making the standard talk to each other would be harder thing to do than figuring out what the gaps are. Yeah, but as long as we know where the gaps are, we can still, try to solve the problem and making them talk and fill in the gaps. So you and I work together to do that. Any other questions?
Okay, the thing I wanted to ask you, Sankey, was just on your final point there when you talked about domain experts and geospatial data experts. So in attempts to fill these gaps, what you're advocating is that geospatial experts and particular domain experts, whether it's navigation or energy services, do need to come together a lot more. So you're advocating a lot. So, and does that mean in the future that we will see more joint working groups being established to look at these types of things?
Of course.
Yeah. You see that as being inevitable then going forward?
Yes, it is inevitable. And then it's just in my country, we are doing all kinds of collaborative work between energy people, transportation people, and BIM people, and other services people to try to do that.
Just that. Okay. Thank you very much, Sankey.
Thank you.
Okay, our next speaker won't be known to many, and that's Scott Simmons from the OGC. And Scott is going to talk about the APIs, specifically tiles and maps. So when we've got a presentation up, Scott.
Thanks, Alan. Yeah, my question is Sankey actually just set up my talk because I'm going to talk about standards that talk to each other and interoperate. And while we're waiting, the only really intimidating thing about presenting in Scandinavia is that all of you locals speak better English than I do. And so I do apologize for my horrible American English. I promise I'll try not to fall back on my native Texas dialect and try to keep it understandable for y'all. Let's see, I just said y'all, so there you go. You're in trouble already. So today I want to talk about OGC APIs, two new APIs, one for maps, one for tiles. Tiles has just been published last week. Maps coming along early next year. But to set the stage, let me talk about the entire environment and family of these APIs. And note that one of the APIs developed, the first one, is ISO 19168. The geospatial API for features. That's OGC API features. Anytime you see something that says OGC API dash, there is likely or potentially could be an ISO geospatial API for that same resource. One of the things we're striving to do, and that was partially successful in a legacy of standards for service and content to the web in particular, was to have consistency and interoperability amongst the different APIs that are providing your information. And so that you can have map and imagery data provided in some different number of ways and presented to the user in the way they can consume it most easily. And what we did in our legacy was we had a number of these W*S standards. We called them Web Map Service, WMS, Web Map Tile Service, Web Feature Service, Web Coverage Service, et cetera. And they each were able to supply content to the end user in the fashion that that end user needed to consume. So if you wanted to just look at rendered map content on your browser or in your application, you pulled up a WMS. If you wanted that map content to be tiled and more efficiently delivered, you asked for a web map tile service. If you needed to query the features independently and make your own calculations, grab a feature service. And all this would be discoverable via catalog service. So that was the architecture of what we refer to as the OWS, OGC Web Services Standards. And you'll recognize WMS and WFS are both also published in ISO as 19128 and 19142 respectively. But in looking at modernization of this approach to data, we took work we had been doing jointly with the World Wide Web Consortium, W3C, and other trends, and how we get data to the web more natively, and also realized that there were some performance issues with some of these standards because they were very large standards that were quite comprehensive in what they did. And could we not take an approach that's more elegant, quicker, simpler, better integrates with the web? And so we started looking at little building blocks we could create, bundle together, and create a service API. And so now you have developed effectively, and there's a little star next to this, an API for each of those same resources I just showed a moment ago. WMS Web Map Service can be considered OGC API maps. Web Map Tile Service, OGC API tiles. So it's effectively, it looks like a one-to-one drop-in. That little star is not quite. At the same time, we also realize that if we take a completely novel approach, look at this from scratch, all new way to work on it, maybe we can deduplicate some of the features and functions of some of these standards and more elegantly leverage each other to get things done. So if you want to go to a map and you need information about a road that's in the map, you can ask a feature service to give it to you. And that just reduces the complexity, believe it or not, of the standards and lets us do this through little building blocks. And they all still integrate. While I have this up, if you read the description of what I said I was going to talk about today, you would have noted I said something about, and then we're going to deprecate these standards. So I'm going to say this verbally. I'm not about to put this on paper yet because one, the policies aren't approved, and two, our membership hasn't said it's okay. But our plan is, yes, we do ultimately want to deprecate, that is invalidate, no, deprecate the old OWS standards. What we want to do is move them to what we refer to as a legacy status. So at the moment, there's more than 500,000 instances of Web Map Server, ISO 19128, published to the web in the world. There are government agencies that have programs of record with 20 years of duration to serve data via WMS, WFS, et cetera. These things aren't going away, and they work. So what we will plan to do is move these to a legacy status, no longer update the standards, but they'll still be valid standards, and encourage people to move towards these more modern APIs to push content to the web. And that's sort of how we'll move forward. So deprecation's a bit of a scary word. Legacy, not quite so bad, kind of means the same thing. But I know it's hard to read. There's a whole lot of APIs. I've highlighted a few. There's more. There's one for styles. There's discrete global grids. There's 3D. There's all sorts of things. We have a whole lot of these APIs. They're all being developed concurrently in concert. We have a staff member whose full-time job is to manage these as a product family, Dr. Gobe Hobana, on OGC staff. So we are coordinating all these so they work together, because the intent is that they all function as a single kind of set of resources you can use. The way that works is a real simple example. You have your spatial data. You have a user that says, just tile up that data and throw it on my mobile device. That's all I care about. Wrap it with a set of common elements, put the tiles piece on it, and it works on your mobile device. Your data is accessible in that fashion. That same data, your user now wants to query it in publish it in WGS84, but query it as feature data. So slap on some feature building blocks, give it a query function, the same data accessible for another user for another purpose. You have a user that needs a new coordinate reference system, a user in Australia dealing with a new dynamic coordinate reference system. Bolt on a coordinate reference system piece, data is usable. And then if you have someone doing emergency management, a fire incident commander, you just slap all these little building blocks on the same block of data, and it's accessible to each function and each person as necessary, and they all interoperate. So that's the dream, the vision, and it's working pretty well so far. Here's an example of a whole number of these. OGC API common, features, tiles, and styles all being used in a single instance. So this same piece of data accesses all these pieces of APIs to deliver the data exactly the way the user needs it. And so these are all the types of resources that you can now call. So if you're trying to build your provision of content to the end user, you can call upon any of these resources, and through this tree that you see, you can link them together quite simply. And each one of those resources is a functional little building block, a little independent standardized bit of capability that you can use independently. And you can take 3 building blocks from 3 different standards and in theory bolt them together and have a novel way to present your data to the end user. And so these building blocks, we have a website dedicated where you can search and discover all the building blocks, get sample code, and understand how to put them all together. Now, specifically, I'm going to talk about maps and tiles as standards. These are each a collection of these building blocks, and they share some building blocks with other standards. I could go into mega detail. I know Sanki said he was going to do something academic. I had a whole pile of slides for you that I'm not going to show you, that we're going to torture you through how it all worked. I'll try to make it much simpler. I've talked about each of these standards being sort of self-contained, but being made of building blocks. But each of these are also published in multi-part, as was sort of illustrated where I described tiling it up for the phone or bring it to the fire incident commander. So the parts are intended to start simple and get more complex. If you use the single first part, the core, you do that simplest feature, the simplest thing to get your data out. And then you just add other parts as you needed. And so you can see maps and tiles have a number of parts collectively, and these all interoperate, because if you think of how a web map tile service worked, it was a web map service that chopped up things in a tile and spit it out. Well, it used maps and tiles. Hence, we have all these parts interoperating. And the building blocks underlie those parts just can be combined, again, to provide your information. So now I'm also illustrating, we have a styles API. And so if you have a data set and you have a collection of entities in that data set and you want to style them and put them out in a map and also tile up that map to make it quickly accessible, just string those little building blocks together, your data is available in a really simple fashion. And I'm not kidding, it's really quite that easy because you already stepped out, too bad. I watched Yari put together a OGC API feature service in an hour over lunch once. He doesn't even code anymore as far as I can tell, so it's pretty impressive. So more specifically, let's talk about tiles. So OGC API tiles just published last week officially. Fairly simple modular architecture. These are the only requirement classes on the left side. So you've got tile sets and an ability to find lists of tile sets. So you can bring in any kind of tile set you want. Doesn't have to be perfect little squares. They can be other gridded systems. The origins of where your data and your geodata lie, and a few parameters, how you select your collections and how you subset date and time. In OGC now, date and time are an equal partner to XYZ. Right, so they're just another dimension for us. And then the variety of representations. This is a really big difference from the legacy of the old WMS and such, is that you have so many more ways to get to your content and push it out, as well as other types of things you can bring in. So working with really complex things like NetCDF and HDF5, which are extremely complex data cube types, still native both for reading and writing from the tile standard. And if you want to do the very simplest, you just grab part 1, the core, and you can make all those snazzy looking maps you see on the right side of the screen. So any of those kind of map representations you're used to providing your users, where they're quickly serviceable, the minimalist core tile standard just gets those out really quickly and doesn't require much else by way of reference. And it's extremely performant. And we can say a number of you who've worked for national mapping agencies and others have demonstrated this. So we've seen some really performant implementations. If you compare what WebMap Tile Service did to the OGC API Tiles core, there's sort of a one-to-one correlation of the general capabilities, but they're done quite differently. And so the nicest thing about these new APIs is they are completely RESTful, and they don't necessarily require that you ask first what capabilities can it serve. And then once you understand, oh yeah, it's going to do that, I'll ask for it. You can just natively receive whatever it's able to provide. It makes that transaction much simpler. The other nice thing about the Tiles API is it supports vector tiles. So vector tile, it's not just for tiling map or raster data. It supports vector tiles. It also supports coverages if you really want to get into deep nerdom here. Maps, really similar to tiles, virtually the same architecture, except there's quite a bit more about the content that is bundled together to make a map, because the OGC API for maps thinks of a map the same way we do when we think of a paper map that was derived from digital data, all the different layers and how they're put together to tell the story and how they're styled, etc. All those kind of pieces and the linkages are necessary, but very similar to tiles. And similar in representations, but a bit simpler. The map is considering that you're starting with either a vector or a raster source primarily to push out to a map. And then all these things using Open API for access. Similar to tiles, the minimalist core of maps, you send a map data set to the API and it is discoverable, findable, and the user can navigate as they need to. It's going to be just in WGS84. It's going to be really simple. It's not going to have the ability to query or interrogate features, but at least it just gets that map out there. And then you add the other building blocks as necessary to bring these things into a map environment. And just as WMS, same kind of features. Again, don't need to query the capabilities, make a whole transaction to even find out what the map's going to do. You can just grab the map and go. This is RESTful only. That's another little star. One of the advantages to the other standards was they were SOAP-based. There are still installations and there are still embedded systems that are more SOAP-like than REST-like. Anyone that doesn't understand that, we can talk about that later. But the SOAP-like stuff is still necessary, and so that is still supported in the old APIs, but we can facade those with these new APIs. And we have a much more elegant way to do styles. That's a whole nother talk for another day, but styling is being dramatically modernized. And it was great to have Zarina on recently because we're working with her in the ICA to ensure that we have a much more robust cartographic capability with our styling API. Last thing I want to talk about comes to something Marlene said earlier this morning. Specifications need to be used, right? They need to be used. If your specifications aren't used, they're worthless, and they need to be implementable. And OGC is now developing all of these APIs in an environment that is integrated with a sprinting process. And so we've done 2 recent sprints I'll highlight, joint with ISO TC211. We did one on the metadata code sprint where we looked at our API for records and ISO 19115 and a few other things about how we integrate metadata with these APIs. When we do these sprints, we bring developers and we bring our experts on these APIs into the same room and literally hack against code and the actual description of the standard as it's emerging, write code in 3 days, test it, and either change the specification language or validate that, wow, all that stuff actually works together. We seldom, in fact, I don't think there's a single case of having less than 5 implementations on the market by the time one of these standards gets released. So we have the community actually implementing, we have the commercial vendors and the open source community working on implementations live while we're developing the standard. And last week we finished one actually dealing with tiles, maps, styles, and how they all integrate and how they all interoperate. And the real benefit again is that if you can prove it with developers from a dozen different organizations and all of them can make it work together, you probably have an implementable standard and you probably have a relevant and market relevant standard. Because you got to be honest, if the API isn't going to go into commercial and open source software and supported by market viability, it's, as others have said, shelf for it. It's not doing anything. There's no value at all to our market. It's just an experiment. So all of these things are tested very thoroughly prior to ever going to publication. And so with that, I'm happy to answer any questions about these standards or any of the other APIs. Thank you very much for your time.
Questions for Scott?
Because it's so easy. It really is. Ask Yari. Yari, you walked out when I bragged on you when you did WFS3 implementation at lunch. Where were we? We were it was a TC211 meeting. And you whipped out a lunchtime implementation. Before that was, we used to call OGC API features Web Feature Service 3. So yeah.
The one thing I would say about OGC APIs is that Audit Survey, we've been looking at them really heavily. In fact, we took part in one of those code sprints. I've took part in both of those code sprints. And to get a group of people worldwide all together, just on what Scott says, validating is hugely valuable. And there's an engineering report comes out at the end so that none of the learning gets lost. They are just a fantastic way to make sure something works before an organization like ourselves decide to invest more heavily. So they are fantastic places to go and learn and really lift up the hood. That's an American word. And have a look underneath, you know. So thank you very much, Scott. Really appreciate it. And we hope that your API program goes from strength to strength. Thank you.
Okay.
Okay, our final speaker today is Jari from the National Land Survey of Finland. And Jari is going to talk to us about something called GeoE3, which is a geospatially enabled ecosystem for Europe. So we'll wait until he gets his slides up and
Thank you, Alan.
okay.
And thank you, Scott, very much for giving this kind of educational part of these APIs. So I will go and dive a bit more into the practical level. So I will not go into the conformance classes or landing pages or how it does work, but more to look into practical settings. So my name is Jari Reini and I come from National Land Survey of Finland. And today I will talk about partly EU-funded project called GeoE3, Geospatially Enabled Ecosystem for Europe. And I directly go into the objectives of this project. First of all, we started it in October 2020. It's a 3 years project ending by the end of September next year. We have participants from Finland, Norway, Netherlands, Estonia, Spain, and then we have also OGC involved in this project. And what we are trying to achieve during this project. Of course, to first have better access and interoperability of geospatial data and also other data. So using different dashboards, combining statistical data, different metadata, for instance, OGC API records. Then secondly, we are doing some harmonization. We are moving from GML to GeoJSON and using these new API standards. And last but not least, also to have a lot of e-learning videos, innovation events and things like that to really demonstrate how these things are working. So OGC is actually establishing e-learning platform where we'll have a lot of different videos, how to take these into use, how to develop. Unfortunately, I'm also talking in many of these videos, so sorry about that. But those will be available early next year. We already have some of them available. So if we are looking what we have done during the last 2 years, so we have so-called GeoE3 platform. It's an integration platform, and we have different tools and APIs there. But at the end of the project, we hope that these tools are deployed also in national platforms. So this GeoE3 platform is a central place. We are connecting to national services and then delivering content through that single access point. But we would like to have also national implementations in the future. Some of the services we have implemented in this platform are listed here. So OGC API features, ISO 19169-1, Actually, we have -2 as well, so coordinate reference systems, OGC API coverages, OGC API records for metadata. Then we have OGC API processes. So we are actually creating on the fly from 2D buildings, 3D buildings, having a so-called extrude method or process in place. And then we are also working with comma-separated files. So we are combining geospatial content and this information from statistical domain using OGC API joins. And it's cloud ready. It's easy to deploy all these tools into different cloud platforms. At the top on the right-hand side screen, you can see OGC API coverages. It's so-called cross-collection query. So we actually ask digital surface model using OGC API coverages, and it actually combines content from Norway and from Finland with a single query. So that's a really nice functionality of OGC API coverages. It works with features as well. So at the bottom, you may or may not see, but there are some buildings, and that's also a cross-collection query where we have buildings from Norway and Finland in one single query and then shown on the screen. We have also buildings in natively LOD2 level available. Those are these reddish and those bluish from Madrid and Helsinki. Those have been extruded on the fly from 2D building footprints. And how we calculate these 3D buildings on the fly. So we have a footprint, 2D footprint, then we have a digital terrain model, and we have a digital surface model, and then we have an average calculation, what is the height of the building, and then we extrude it using OGC API processes. I might give a demo after this presentation so that we have some standards in action. So current services included in the platform, I will not read all of them, but we have base maps, we have buildings, roads, DTM, DSM, some temperature, weather information, wind speed, sunshine hours. So we have 3 different use cases during the project. We have a solar energy potential use case for buildings. So that's why we have sunshine hours, for instance, currently only from Finland. Then we have also ITS use case, where a company from Norway called Aventi is implementing some of the functionalities and include these services in their ITS platform. So Trond is not anymore here, but these kind of functionalities will be used in his domain as well. And then we have one smart city use case between Tallinn and Helsinki, where we are using these 3D buildings also. So how we started this work, we have national data sets from different countries. Those are in your databases. And then all of us, we have not deprecated, but maybe in the future, legacy services, namely WFS and WCS in the national platforms, and then those are connected to GeoE3 platform, where we have tools to deploy these OGC APIs. So I could say that GeoE3 platform is currently a facade on top of national WFS, WCS services, and then you can get tangible feeling and results how OGC APIs look alike with your own data without even doing anything, but we are doing it in a central way. And I have a little bit of invitation to join in one of my next slides. So as on the right-hand side, your data, your service. So we already have content from Slovakia, who is not involved in the project. We will have some content from France, from IGN France, in early January, I believe. We have had discussion with Germany, so we will get some 3D buildings from Germany. And the reason why we tried to get content from Germany, as we have Netherlands as a partner, we would like to use this cross-collection, cross-border functionalities. It's rather difficult to have cross-border things between Finland and Estonia. There is 80 kilometers of sea between, so it's not very good use case. And up north in Norway and Finland, I would say that it's not that occupied area. We don't have too many buildings on that region, so trying to be more into the Central Europe. So this is the status at the moment, but our ultimate goal is to move more that we have national OGC APIs. We will not use deprecated things or legacy. I actually had in my slide in one of the meetings, instead of OGC web services, I had deprecated OGC web services. But for the audience online as well, those will not be deprecated. Those are still very valuable, and we will definitely use, for instance, WMS, WMTS also in the future. But in this project, we are trying to move into the OGC API field. So that's our goal, that in national mapping authorities, they will establish these services on their premises, or if they use cloud platforms, whatever, but have in their own infrastructure. And then we have different customers, different use cases, different services who can use directly these services. And GeoE3 platform is one customer, at least until the end of the project. So some screenshots. So we have these different collections. We have divided those by different countries. Like in this case, we have buildings from Finland, Norway, Spain, and then we have a map user interface where you can click on those and see more information. So this is the HTML representation. But of course, we are following the standard, so we have other encodings as well. So you can have a GeoJSON look or JSON encoding, but this is maybe much more nicer for you to look instead of GeoJSON. On the other hand, it looks like I'm more professional if I have JSON there. So I don't know what is the good or bad in this context. So invitation to join. As we are right now in Sweden, in between Norway and Finland, there is a country, Sweden. It would be nice to have maybe some building data from Sweden, maybe digital terrain model as well, surface model, and also roads. And then you could see some 3D buildings via OGC API features. So, and other countries as well are more than welcome. But as I take this as an opportunity, as we are in Stockholm in Sweden, that kind of my personal offer for you to get some 3D buildings. Sorry, wrong direction. So then I might try to make some demo. So the address is GeoE3platform.eu. And now so it was only shared by, yeah. That's correct. Okay, so this is GOE3platform.eu. Feel free to test yourself. It's publicly available. We have different contents available here. So like I said, for instance, buildings. Without Sweden, I can show the current list, Finland, Norway, Netherlands, Spain, Estonia, Slovakia. We also have metadata, buildings metadata via OTC API records available. I will not go into this one. Maybe looking into processes. So we have extrude building process, very easy interface. So we have two different input parameters. First, we need to know the country, from which country we are extruding buildings. And then we need the persistent unique identifier for that building. So what that actually happens when you send this process, this information to the process country like NO and ID 1234, we will retrieve GML data from that particular building. We have a building footprint, and as an output, we then deliver a city-JSON object, which you can then show in your application. I will show it just at the moment, in the moment. So here we have buildings 3D. If I go to collections, I can take, for instance, Norway. We don't have the whole coverage of Norway. We have two different regions. So trying to zoom in. Let's go close to Kartverket or to Hörnefors. View that area. Okay. Some buildings. Oh. Zoom. I will not take a very big process just to get a feeling that we have buildings from here. Okay, that's good. So now I made a so I made a request from this region. So it sent these IDs from these buildings to their processes, and then ultimately I get these buildings as 3D with LOD1 because we don't have the roof type and anything, but just to demonstrate that this is the offer for one particular country here right now who could deliver content. So yeah, that was 3D buildings, and then we have a lot of other things. We have roads also in 3D, so we have made a similar procedure for that. Digital terrain model, surface model, etc. So a lot of things are ongoing right now. We have OGC API joins also available, so we can combine content. So I would say this was an example of standards in action and these new OGC APIs using OWS services in the background. And hopefully by the end of September next year, we will have these as a national implementations also available. So thank you very much for your attention.
Thank you, Jari. Does anyone have any questions for Jari?
Yeah.
Do we need open data to enjoy this?
I would say as this is currently open service, then it should be open data. And I know there are some restrictions in place. So I would say that's an issue. But if we, on the other hand, think about open data directive and these high value data sets, which will be in place starting next year, and then we have a 16-month implementation time. Buildings are in that team as well. So in that case, also by the regulation from European Union, also Sweden will have open data for buildings.
Okay, and
But not yet.
anyone else? Good for Jari. Olav?
Yeah, very interesting. Very interesting, Jari. Am I right if I see this as a continuation, a generation, and also extension of the European Location Framework project that went along for 5 years until 2016, where many of these services you were showing also were used? You retrieved, from what you showed, it seemed like Finland was the only one to have OGC API for features in action. The other use still WFS. And you also mentioned you could have one retrieval and then combine the data. That was a big difficulty with WFS in the old days, where you in Finland had to make some ingenious program to really connect from 2 different countries.
Yeah.
So how do you do that now?
So starting with the first question, and thank you, Olaf. That's indeed the case, that this is really the continuation of starting maybe from SDIN, then ELF, and then Open ELS. So we have had several different EU-funded projects related to this context. In some of these projects, we really tried to create the central repository and put all the data into one place and then deliver it. But it requires quite a lot of work to put everything in one place. So now we have this facade implementation way. When it comes to these collection queries or cross-border use cases, that's the advantage of OGC API features, that it can actually create this kind of queries without us doing anything. We are using in this particular case a tool called PyGeo API, Python-based open source implementation. And if we just have these services as a service provider put into this PyGeo API, it can really generate this cross-collection query automatically. During the ELF project, we really had a lot of bespoke development and a lot of difficulties in harmonizing content. But this is really a big enhancement when it comes to this OGC API features. And also, on the other hand, JSON is quite much easier to use than when it comes to very verbose GML content.
Okay. Yep.
I have one question. Thanks for the presentation. My question is, how do you cater the restricted area? Do you remove the building or not?
Pardon, I didn't get the last part.
How do you cater the restricted area?
The distinct area.
Yeah. So do you remove the building or you just leave it without no names?
We have published all the content which is not restricted at all. So we only have data which is publicly available. Okay.
Any other further questions? One question from myself, Jari. You say that this project's ending next year.
Yep.
Yep. Other discussions about plans for the future thereafter?
Very good question, Alan. That has been many times the case when we have these EU-funded projects. They have a time period, and when it ends, everything will be shut down and you take the results. there is a new initiative by European Union called EDI. Those are innovation hubs, and there will be an innovation hub called LIH. It's a location innovation hub. There are more than 100 different innovation hubs in the future or next year starting in Europe, and we got funding for that. So we will actually take everything from this to this location innovation hub, and it has already promised it will continue first three years, and then we have a option to continue 4 years. So at least 7 years ahead, it should be stable, and these services should be up and running.
Yeah, it's not just the EU that suffer from starting projects and then a gap and then restarting. I think we have that in the UK as well. So yeah, thanks for that. If there's no other questions, thank you very much, Jari, for your time. That's fantastic. I'd just like to just to sum up really, and my summing up has really just got a lot of thanks. So the first thing I'd like to say is to thank the speakers for giving up their time, producing the slides, and coming here today to speak. It has been a real pleasure for me to say a few words between the speakers. But if the speakers didn't show up, then I think I'd be struggling, and you wouldn't want to hear me talk all day. So thank you very much for the speakers. And the other thing that did strike me about this program was just the wide breadth of areas that we work in geospatial. So you've got Chris with his land administration. It's a world away from the UM models that Heidi was talking about, and indeed the GeoE3 program that Jari's just told us about. And then we had addresses in between and emergency geocells as well for response to fire in Sweden. And also I would like to thank our keynote speaker, Maren, for coming to tell us about the planning and development side here in Sweden. So that's my first vote of thanks. My second vote of thanks is to the SIS people in the room who were here early this morning, and so thank you to Friedrich and to Christine and to Ulla for their support. It does look like it's a really well-organized event, but we were like a swan. So on the top it's nice and smooth, but we're actually paddling away like this underneath, just to make sure that everything has went well. And then the final thanks really is to yourselves for coming and listening and putting over some really good questions. And it's only by speakers exposing their work, having people ask questions, that make us go away and think again and innovate and go on and produce the next thing. And equally, thank you to all the people that have joined online. I hope you got something from today, maybe not sitting at your computer all day, but hopefully you've got something from some of those presentations. So with that, thank you very much indeed. And I'll close the meeting. Thank you very much indeed. Thank you.